So there you have it. G-Sync is a premium solution that we are very proud of. It offers certain technologies that we can claim exclusively are supported in G-Sync. Things like we don't have a minimum refresh rate. You never see ghosting with G-Sync because we have variable overdrive. We support SLI. You can also play G-Sync in a multi-monitor configuration. So for those folks who play surround gaming, you can hook up 3 monitors and have G-Sync running on all of them. We also have windowed mode support. We're the only ones to support this.
The limitation in the past where below the minimum frame rate refresh rate of the monitor, G-Sync was disabled. Is that a driver update or is that an updated hardware in the screen?
Yeah, so in the case of desktops, that logic sits in the G-Sync module. So what it's doing is it's detecting the incoming frame rate. Based upon that, it's changing the refresh rate of the panel, doubling, tripling, or whatever have you, and repeating the frames.
So is that feature now that's compatible to existing G-Sync monitors?
G-Sync monitors today do that. That feature is not new. All G-Sync monitors do that. There is no minimum refresh rate.
Right. I've been led to believe otherwise.
No, not for G-Sync though. There is no, G-Sync works all the way down to 0 FPS. That's always been the case.
Okay.
And in the case of notebooks, all that intelligence sits in the GPU. So it's a driver update for notebooks.
Describe what AICs can do in terms of customizing GeForce memory configurations, clock, that sort of thing. What are they able to do?
They're able to have custom cooling solutions, and because of that, they can overclock as need be, and that's no different than what's happened in the past. So you will see the stock base clock on 980 Ti is 1 gig, and the boost clock is 1075 meg. But you will see different flavors of that from our different AIC partners.
All AIC cards have to be 6 gig.
They all will be 6 gig.
Okay.
Yes.
You mentioned being able to run everything now on one card or whatever.
Yes.
How important is that to you? I mean, you're going to lose a lot of sales in multi-cards.
That is the way I'm taking the consumer perspective. They only need to buy one 980 Ti card to enjoy 4K resolution, and I think that's a huge performance value that we're delivering to consumers.
And power requirements.
A lot of end users, when they first heard about the concept of mobile G-Sync, because there was a few notebooks they shipped early,
Yes.
they raised the question in various communities, okay, NVIDIA is able to do this G-Sync system on a notebook.
Yeah.
Why do we need to buy a panel with the FPGA module in it, and why is NVIDIA doing this? I mean, if they can do it on a notebook, what the desktop is a bit redundant. Can you elaborate and address what advantages the G-Sync module on the desktop monitor does compared to the notebook, and what differences in the functionality, and to address the concerns of the users who claim, because you can do it on the notebook, that more prompts the desire for VESA adaptive sync versus having the whole the hardware ecosystem with the G-Sync.
Right. No, good question. So in the case of monitors, you have the scalar chip there. And let's say hypothetically, if we had done the same G-Sync implementation on monitors that we have on desktops, it wouldn't work because the scalar chip sits in the middle. The scalar would interfere with the GPU driving G-Sync signals onto the panel. We had to replace the scalar. There's no way around that. And so you need a G-Sync module in desktops that you don't need in notebooks. It's a different implementation, can't be helped. But having said that, the performance is just the same because we're doing all the other things in the GPU that's happening in the module, things like variable overdrive. So performance-wise, they are at par, and I hope that's the impression you take back after the demos we look at today.
So theoretically, say multi-refresh on a desktop monitor wasn't there in the first place, then the platform's desktop and notebook can be on par, and you can do it all on the GPU and you can do it all on the driver, and in the first place the module wouldn't be needed.
Sorry, say again?
we've had we have had multiple refresh monitors, for maybe 25 years now, and say monitors and
When you say
desktops.
multiple refresh, what do you mean? You mean variable refresh? Or
Multi-sync. So, let's say desktop monitors were only a single refresh, like our notebook screens.
Okay.
Then then we wouldn't have needed the module in the first place. Is that right?
Yes, but what G-Sync is about is variable refresh. If it was a constant refresh, that's not G-Sync. Right? The point of G-Sync is we're doing variable refresh to overcome stutter and display, stutter and tearing.
So the point of the module is from the desktop implementation to overcome the limitations of the scale and not to implement certain G-Sync features, because as you said, they've been done in the GPU on the notebook side.
The principal function of the module is to overcome the limitations of the scale. That's correct. And because we have that, we built intelligence into it to do other things as well. But we can now pull that back into the GPU on notebooks. As far as VESA is concerned, we think of that as a protocol for communication between the GPU and the panel. That's really what it is. And that's why it doesn't have so many of the functionalities that we offer with G-Sync. It has a minimum refresh rate. Below that, you will see tearing and stutter. It does not have variable overdrive. So you see ghosting with VESA and FreeSync. And we obviously want to back the technology that's superior and delivers the best experience.
With this update that you're announcing at Computex with the new screens, is there any limitation on OEMs for if they want to implement other protocols in their screens, for example, FreeSync or Adaptive Sync? Can they do that with the G-Sync branding?
No, the NVIDIA GPUs do not support FreeSync and Adaptive Sync.
Yeah, but that's not what I meant. So I'm saying from the monitor OEM side of things, if they want to make a monitor that supports multiple systems.
I believe there is a monitor that supports multiple
Yeah,
systems.
but there was a bit of controversy over that. That was an Asus one.
The BenQ one I'm talking about.
Yeah, but there was an Asus one also. And is there anything in the program that from you guys you go, oh, there has to be a G-Sync and you can't have the others in there?
We are not mandating that it has to be a G-Sync monitor alone, which is why you have monitors which support FreeSync and G-Sync.
G-Sync for notebooks, it's not at all backwards compatible. You couldn't shoehorn it into an older Maxwell notebook.
No, you cannot. And the reason for that is this: to support G-Sync on notebooks or desktops, we have the panel approval process. So the panels that you see on these notebooks have been approved for G-Sync.
Okay.
The ones in the past were not tested, so we can't guarantee the experience on that.
Right.
But is there not also a custom IC or circuit board within a G-Sync compatible monitor?
Not in the notebook side.
But yes, for desktops.
For desktops it is. So you need the module for desktops. But I think the question was, if I understood that correctly, it was about supporting it backward compatible for notebooks.
What if there is some older, say 6 months ago, there was a laptop released with a panel that you have now approved? Is there any whitelisting or blacklisting in terms of the software if the user wants to, if they have the supported hardware, you just haven't validated it?
The thing is that panel, although the panel model is supported for G-Sync, we test each panel unit to make sure that it's free of defects. And anything in the past has not been tested. So we don't allow G-Sync on those panels.
So it's a platform. It's a platform level whether you enable or disable it, because you approve the platform from the platform / firmware level and from the branding perspective. That's the only way to get it.
Yes.
Yeah.
You can eventually release a GeForce card that can run 4K games 60 frames a second with no drops.
Yes.
Does G-Sync become redundant?
Does G-Sync become redundant? If you can guarantee that at all times your frame rate is at the maximum frame rate of the panel, then you will not see tearing and stutter even without G-Sync. But the fact is, the way games run is that you can average 60 FPS, but that does not mean you will always have 60 FPS. Your frame rates move all over the place.
But is there room for it to expand to, say, I don't know, having an effect on 3D gaming at 120 Hz or anything like that?
Whether G-Sync can help with 120 Hz
That's
3D
right,
gaming?
yeah.
We have 120 Hz panels which we support G-Sync on.
Yeah.
So if you were to play 3D games on it, G-Sync works just the same. You won't see tearing and stutter.
Doesn't that depend on how you use the 3D game in terms of passive glasses or VR headset or?
Right now, we don't support G-Sync on VR headsets.
Yeah.
So
Obviously, because they have their own screen inside. So you're saying the only way to use G-Sync with 3D, you have to have some sort of passive glasses system.
Well, at the moment, yeah, we don't support G-Sync on VR headsets at the moment.
Yeah.
It's not supported in virtual reality. G-Sync is really there for gaming monitors at the moment. That, yeah.
That raises an interesting point, doesn't it? Because one of the challenges Oculus are trying to overcome is latency. Would G-Sync not offer a pseudo solution to that in a VR panel?
G-Sync by itself does not add latency at all. So if you compare, and you will find that it's the same latency as V-Sync off. So G-Sync by itself is adding no latency at all.
Okay, and I forget the latency word. Is NVIDIA in discussions with Oculus over using G-Sync for their upcoming panels or any other VR vendor?
I cannot talk about products that haven't been released, obviously. But stay tuned. I guess I'll leave it at that.
Do you agree that G-Sync would be enormously beneficial to VR headsets?
I believe it could be beneficial.
Those 10 and the 350 million devices
Yes.
that are out there.
Yes.
Any comment on HoloLens and augmented reality versus virtual reality and maybe how you'll support that?
At the moment, I'm not aware of our plans to support augmented reality. And frankly, I'll have to check back and get back to you on that. But I'm not aware of our plans to support augmented reality at the moment.
And all of this that you're talking about is dependent on DX12, is it?
What is?
Everything we talked about is really dependent on DX12 coming out.
It's the new features that I talked about, be it conservative raster or be it volume tiled resources. Those are the advanced features that you only get on 980 Ti and second gen Maxwell. But that's the extent of
G-Sync,
DX12.
that's separate.
Yeah, I'm not at that.
And during your brief note, the notes about the DX12 update, you didn't address multi-threading. Can you explain how going forward, when we start to get DX12 games, how multi-threading with NVIDIA drivers and optimizations will help the gaming experience?
Yeah, so obviously one of the big benefits of DX12 is that it supports multi-threading. So I talked about how it shifts the workload from the CPU to the GPU. The CPU is no longer a bottleneck. And with NVIDIA, and frankly with any DX12 supported GPU, you will get that experience. So you will see the benefits of multi-threading, and you should see CPU bottlenecks go away. Basically on any of our cards that support DX12. And we are supporting DX12 on Fermi, Kepler, and Maxwell GPUs.
Do you have any update on support DX12 driver for Fermi? Any comment on support?
Yeah, so Fermi will support DX12, as will Maxwell, as will Kepler. It's just that the advanced features I talked about, DX12_1, that's only going to be there on second gen Maxwell, not on Kepler. But Kepler will run DX12 games, and Fermi will run DX12 games.